some new additive manufacturing codes committees, there's some new journals, things like that. Here at SAMPE, we're very interested in the industrialization of composites manufacturing. So I really appreciate Kasim's nice introduction in the beginning. You guys are very highly organized. So I'm going to report back to our CEO that, you know, we have to really learn more from our neighbors. Actually, the border should be opening up soon, right? So once we do that, get the hockey players up and down, we'll do that. But I did want to share, Kazim, we are launching a materials innovation and advanced technology forum for January in Huntington Beach, California, and actually in person. So I'll share some information with you after, and if you can circulate it within the group, that would be very useful. But Peter, thank you for the warm welcome, and I'm glad I can join the group.
Nice to see you. So what's the answer now? That's where I was going.
So I think Stephen kind of alluded to it quickly that we don't have a solution right now. I think what we were trying to get at is how you would approach this concretely as a first move. Like, would you make another panel and see if it does it again? Would you do some like more mechanical testing? You know, we just want to see a bit how people would do this. Some people in the breakout rooms mentioned do a very detailed fishbone diagram. Someone mentioned doing
one of the questions we had. I mean, this is Claude. We had the breakout room with Raj and Nayant and was the fourth person. But the question is, how did you monitor the cure?
Yes.
In terms of you know, terminal profile through the thickness. So obviously the volume has something to do. We're talking about non-uniform temperature distribution within the panel, maybe through the thickness, could be exotherm, or it could be maybe there's a little bit too much humidity left in the Kevlar fiber that could generate a little bit of vapor that would result in delamination or blister or whatever. So that's basically the three items we came up with. As far as redoing, yes, it's the next step is always difficult. I don't know if you have ever done a panel, 24-ply panel with the same resin system and carbon fiber to see if it's you get different results. Or
I think because then we're a bit out of time and maybe going a bit overboard.
Sorry, that's what I wanted to just mention very quickly. Maybe I will just go very quickly, and thanks, Claude, for mentioning that. But we also want to talk about other breakout rooms, so maybe I will just name them. So breakout room 1, do you want to quickly talk about what you discussed?
Were we breakout room number 1?
You were 7.
7, I think, yeah.
I think I was part of breakout room number 1.
Perfect, go ahead.
With Jordan, I think it was us. So and Desiree and Yini, if I pronounce correctly. And my name is Romain. And so what we discussed quickly in the time we had was, one suggestion was to do a more like deeper fishbone diagram to see what were the possible origin of the problem. And another proposition I made was to do like microscopy of the profile, cutting it to see where is actually coming from. Is it a porosity, and is it air or something else like a gas vapor? As been mentioned, it could be another gas, not just, it could be water or air or something else. So maybe that could help us find the root of the problem.
Thank you. Breakout room group 2. Go ahead.
Okay, hi, my name is Farzin. I was in room 2 with Stephen. Yeah, we introduced ourselves and discussed this problem. I, of course, had suggestions to find out what is the reason, but I also suggested 2 solutions, one solution actually, then another one came to my mind. I don't think that when you work in this kind of industrial situation, you need to investigate very deep at that moment with that time tight deadlines. I believe they can, because they know that it satisfies the requirements. So probably it is okay mechanically. They can inject resin or they can paint this. I think this way they can solve the problem with the
Perfect.
customer.
Thank you. So group up room number, should I say 3? Do you remember your group up rooms?
Number 2, I think we were number 3, Kazan.
Oh, you were 3. Perfect. Thank you, Claude. 4. Okay, so I'll go 5.
Hey, Dr. Kazim, it's Karman here.
Hello.
Hi. I guess for us, we did more of a networking session, but I guess I'll take a stab at it. I think I would probably check the processing parameters. Like I agree with the gentleman before, Claude. When you have thicker panels, you just want to check the thermal properties, how it basically changes as you have thicker panels. And then, of course, any processing parameters, the heat, and just even like the room that you're in, the vacuum pressure, all that kind of stuff, you would first check.
Thank you. Group 6.
Sure. So same thing as Carmania. We just did more networking and didn't discuss the problem too much.
That's good. And group 7.
Do you want to go JP or Levi?
Sorry, Peter, you said there was a student who had a solution. I forgot that, but anyway.
Oh, somebody else, I think.
Okay.
But we are going as well, because it's a thicker area, maybe look at exothermy or...
I think you got to separate if it's a mechanical, or obviously chemistry makes a big difference too. But you know, you got aluminum plant, very hardly attached, well held down and fixated aluminum against the materials. And at your 24 levels, your curve may have some big mechanical differences. That was one thing that we were talking about.
Thank you.
I was a bit more on the material side, but maybe a DSC, do some analysis, you destroy or something happened.
So to just, again, I'm conscious of time, and to just make sure, I think we can wrap up in 3 minutes. So I'll just give it back to Steven and Jordan to complete. I think they have one more slide, maybe. Go ahead. Thank you.
Yeah, we'll make it really quick.
Thanks.
Yeah. To answer your question as to all those great suggestions, many of those are things that we tried. To give you the spoiler alert, like we said, we haven't solved it, and we spent a lot of time going down the wrong path. One of the big issues was our background, or a lot of the problems we'd had recently were out of autoclave to do with breathing and air evacuation. And we spent a bunch of time focusing on things like that, which was completely inappropriate for an autoclave cured part. So we're still working on it, but a lot of the ideas that were raised were things we did investigate, and only one person mentioned where we think we're going, which was humidity uptake in the Kevlar. That's the avenue we're on right now, and knock on wood, we'll know next week.
I've seen that happen.
Okay, great. Maybe we'll talk more after.
Maybe I can comment before leaving, but the purpose of these breakout sessions are more networking than solving the problem. So don't feel bad if you come up with something different. But that's a great networking, so people can know each other and establish a connection with people they don't know. So it's a good thing.
Perfect. So yeah, just to wrap things up, as part of the package Kazem provided us, he wanted us to maybe touch on a couple final thoughts. First, for anyone who's a student about to go into industry, and two things were some things we know now that we wish we knew before graduation, and some aspirations we have in our field of work. Just really quickly, hands-on experience and networking are both things that people know, but maybe don't focus on because it's not where they're comfortable, or it's outside of what they do in their graduate studies. But I can't stress enough that hands-on experience working with products is invaluable. And because of the modern reality of a job gets posted, 1,000 people apply within the first hour, networking like this is invaluable. Make connections with people at companies that you're interested in. Don't hesitate to reach out. There's no harm in sending someone a message on LinkedIn. The worst thing that happens is they ignore you. Don't be annoying about it, but you need to make those connections at places that interest you, because otherwise it's very hard to stand out from a LinkedIn posting or an Indeed posting. And then some aspirations for Jordan and I. As you saw, we work in low volume custom products and relatively low tech. So we'd love to see the opposite end, a high volume composites production, or a high tech AFP and other sorts of fun technologies. And something that you may miss if you're in grad school now and you end up in industry, it's hard to do pure R&D and pure product development without, I'll call it, commercial constraints. And that's fun. We all enjoy that, but it's very hard to find a position where you can spend a lot of time on that. So that's something Jordan and I, to some extent, both miss. And then last thing, I said networking is important. Do not hesitate to reach out to either of us. We're happy to field any questions you guys have. We're hiring aggressively, full-time positions and internships. We have more work than we know what to do with at the moment. There are some big programs coming through MDA. The titles are on the slide. You guys can Google them afterwards. And the link to our website is there if you want any more information. So I'll end by thanking 30 people for sticking through it for this hour and 15. That's not bad. We got 75% from what we had at the start. And
Great, yeah.
Thank you, Kazem, for reaching out to us. It was a great opportunity. We really enjoyed it.
Yeah, thank you very much.
Thank you, Stephen. Thank you, Jordan, for the presentation. And again, thank you everyone for attending. And we'll hope